All right, so for section 7, which is the second part of part 2, what we're going to try and do is we're going to look into the active and reactive power and apparent power of this circuit from the previous part. So apparent power, the magnitude of apparent power can be calculated as the basically product of the RMS voltage and the RMS current. We know the RMS voltage, or at least we can calculate the RMS voltage of this circuit because we know that the peak-to-peak voltage is 6 volts. So if the peak-to-peak voltage is 6 volts, we can easily calculate the RMS voltage. However, we don't know what the RMS current is. So we need to take that measurement using our multimeter. So if we take a look at this again, so basically we're going through, the current's going through here, going through this for this resistor, then it's going through the decade box and going through these capacitors and going to ground. If you remember, I left this wire here. Doesn't really serve much of a purpose. In theory, this could be connected over here. The reason I left it there is because that's where we're actually going to be we're going to be using this wire to take the measurement. If you'll remember from part 1, if you've done it already, that the current measurements are typically measured in series with the current that you're trying to measure, as opposed to the voltage measurements, which are measured, it's like these are measuring the voltage in parallel. So it's we place these in parallel with these things that we're trying to measure, but we have to put, for the current, we have to put it in series. So we actually have to break the circuit in order to measure those. So in order to do that, we're going to use plugs into our multimeter. So this plug, we're going to plug into the milliamp and microamp slot. So we know that the current's going to be pretty small, so that's what we're going to use. In theory, if it was going to be very large, we could use the 10 amp. And then the other one, so we have another one, and it's going to get plugged in to the COM position, which is the ground. So the other end of these, so the other end of this essentially is this. If you press it, I don't know if you can actually tell, a little hook is coming up and down. So you can use this to hook on to take some measurements. So we're going to place that hook onto this end of the capacitor. It doesn't actually matter which capacitor we hook it onto, because all of these ends are all together. It doesn't matter which one we use, because they're on the same bus. They're all connected, so it doesn't matter which one. But for the other end, so for the ground, for the low end of it, we're actually going to break the circuit by unplugging that wire and plugging that in right there. So essentially what we're measuring, we broke the current, we broke the circuit right here and put an ammeter, or I guess it's a digital multimeter, into that position. So it's going, instead of going from here to here, it's going through the multimeter to ground. So that's how we would take a current measurement. So for current measurements, we want to make sure that we're using these over here. We want it roughly in the millivolt range, milliamp range. So let's actually change it to that. We're going to take a look at it, and it's going to say 0 milliamps. So the reason it says 0 is these multimeters default is in DC. I don't know if you can actually see it up there in the corner, but right there it says DC. So in order to change that, what we want to do is we'll hit mode, and you can actually get the reading in milliamps. So it is roughly, there is a decimal in there. I'll see if I can zoom in there on it. So yeah, so there's a decimal there, so it's 0.74 milliamps. If we change it to microamps, because that would be about 740 microamps, right? It's going to go back to 0 because every time you switch it, it assumes that the default is DC. So we're going to have to hit mode again, and we can get our more accurate reading because we're closer to the actual measurements. So it's about 666 microamps. So that is the RMS current that we are measuring. Like I said, we already know the RMS voltage. We can calculate the magnitude of the apparent power. The angle of the apparent power is just your impedance angle. So if you had to theoretically calculate that for section 6, or the first part of this one. So if you calculate that impedance angle, and then you can actually, if you look in the lab report, it talks about reactive and active power. Active power is power that's dissipated over this resistor and this decade box, and then your reactive power component is coming from your capacitors over here. But you can calculate how much your reactive and active power is, since you know the magnitude of the apparent power, you know the angle, and the you can just the opposite. So the opposite leg of the triangle is the reactive power, and then the adjacent one is the active power. So now that you have those measurements, again, you can use this and that and make those calculations. All right, so this was at 50 hertz. So that was the reading at 50 hertz, but we also need the current reading at 500 hertz. So let's change that to 500 hertz with the function generator and get a reading there. So this will be your reading. It looks like about 832 microamps. I don't know if I stressed that before, but there's a micro there. So 832 microamps, and so that's the same circuit as before, only the only thing we did was increase the frequency from 50 hertz to 500 hertz. All right, so that is the end of part 2 of lab 3. There are a lot of individual theoretical calculations that you should attempt on your own before compiling them as a group. Additionally, any of the readings that I took off of here, you can just write down. You do not need to have a screenshot to prove that you took them. You can just write down the readings. So when I read the RMS current, when I read the peak-to-peak voltages for channel 2, the phase changes for channel 2, all of those things, when I adjusted them to what it says to do in the lab, and when I adjusted them to that point, you can see the measurements, just write those down. So you don't have to include any screenshots of those or anything. But you will have to write those down whenever it asks, like, what is the peak-to-peak voltage and the angle of channel 2 with respect to channel 1. You need to write those down, and then you also need to do attempt the individual calculations of what's actually the theoretical impedance using the voltage divider equation, calculate the active and reactive power, stuff like that. So you're going to have to do those individually and then combine them for the rest of your group. But again, you don't need to provide any screenshots or anything. You can just write down the physical numbers for this part.